All right, so the next thing we're going to look at is the composition of functions. So what this is looking at is run a function, say g of x, get an answer, and then use that answer as your input to another function, in this case f. So for instance here we say g of x is x plus 1, so we've got that, but then take that answer. Take the x plus 1 and plug that in for your x in the other function. So we'd have f of, instead of just x like normal, now we have f of x plus 1. What do we do whenever we see x in the f of x function? We square it, so we're going to take x plus 1 and square it. All right, so f composed with g is what we're looking at. And again, the domain, let's read it down here. The domain of f of composed with g is the set of all x in the domain of g, such that g of x is in the domain of f. So it has to work twice, essentially, is what we're looking at. And we'll see an example of this. Hopefully it'll make more sense with an actual example. So let's go ahead and take a look. First one, example 5. F of g of x. We're going to read it backwards. The second one comes first. G, let me say it like this, f of g of x. The second one is on the inside. So we're doing f of whatever g of x is. In this case, it's 4 minus x squared. All right, so that's our input into f. What does f tell us to do? X plus 2. Normally it would be x, but in this case we're going to take our input and plug it in. So we'll say 4 minus x squared. That's our x, and then we're going to do the rest of the function plus 2. So it's x plus 2, and in this case the x is 4 minus x squared. We'll go ahead and clean that up. Negative x squared, and 4 plus 2 is plus 6. All right, let's flip it around and see what happens when we go the other way. G of f of x. So that's g of whatever the f function is, x plus 2. Normally g says 4 minus x squared. Instead of x, we're going to use x plus 2. So this is 4 minus, and I'm going to leave it in parentheses so we remember to distribute that negative, x squared plus 4x plus 4. I FOILed to get that answer. And so we'll say 4 minus 4, because the negative distributes. We'll end up with negative x squared minus 4x. Notice how f of g of x is very different than the answer we got when we did g of f of x. So then they say plug in negative 2. We know already that g of f of x equals negative x squared minus 4x. From down here, we've already solved that part. So let's go ahead and plug in negative 2 wherever we see the x. Be careful with our negatives. Negative 2 squared is 4. We put a negative in front of it. Negative 4 times negative 2 is positive 8. We plug in negative 2, we get out 4. Go ahead and try this on your own. All right, we want f of g, we want g of f, and we want g of g. F of g of x is going to be f of x minus 1, which is going to be x minus 1 squared, which is x squared minus 2x plus 1. G of f of x is going to be g of x squared, which is going to be x squared minus 1. Final answer. Now g of g, we don't have to compose with separate functions. We can do it repetitive on itself. G of x is going to be g of x minus 1. And so wherever we had x before, we plug in x minus 1, and then minus 1. So we'd have x minus 2.